What is this YouTube channel about? First of all, please check the playlist, because I get emails from people saying that, well, we don't see any videos. Well, you have to check the playlist. I have put everything organized in playlist. Anyway, my name is Ruwan Rajapakse and I'm an engineer, and I do these YouTube videos in subject matter that is current, and artificial intelligence. I have physics, I have mathematics, I have engineering, and any other material that I think would have some interest to viewers. So far I have following material. In physics, I have Einstein's theory of relativity, actually General Relativity. I have covered the metric tensor and the Christoffel symbol and the Geodesics. And I decided to put this Erich Kretschmann's attack on the General Relativity, because if you check the YouTube, so many people are saying relativity is wrong and this and that, but all these YouTubes are wrong, and only one criticism of Einstein's theory of relativity have stood the time. In 1917, Erich Kretschmann made an attack on general theory of relativity, and that I have. What he said was that Einstein did not develop his theory from scratch, from assumptions, and then build up like the way Newton did. But Einstein did was pick a tensor here, pick a tensor there, put them together. He's talking about the Reimann tensor that Einstein got, and the Ricci scalar, and then put them on one side and called it curvature of space-time. And the idea of space-time was already established by the time Einstein started to work. By Marvin Minkowski established that. And then on the other hand, he put the stress energy tensor, and then he said, well, see, it works. And then that's not it. I mean, he then showed that his equation will work on any coordinate system. You could move, this equation from Cartesian coordinates to any circular radial coordinates or any curvilinear coordinates. It still works. So any curved coordinate system, the Einstein's equation works, and that means that Einstein's equation, the field equations, are true. It's a part of nature because it works in any coordinate system. But Erich Kretschmann said that alone is not enough to prove the theory is true, and you could take some other equation and show from some mathematical trick that it has a covariance form, or it could work on any coordinate system. And Einstein agreed with that, but Einstein gave a challenge saying that, okay, maybe somebody else could show an equation that would work in any covariance or any coordinate system, and that is called the covariance form, and then we can talk. But so far, after 1915, Einstein came up with this theory. So far, nobody has come up with any other equation. But that doesn't invalidate Kretschmann's argument. So this debate still goes on. So I thought it's an interesting thing to talk about, and it's not in YouTube anywhere. I mean, you have to read papers if you want to learn Kretschmann's attack on general relativity, and I think I'm the only person have this on YouTube. And this is the only valid attack on Einstein's theory of relativity. And then I have Raychaudhuri equation, which is very important equation. The importance of this equation is growing because, as for Raychaudhuri, geodesics of matter which should come together and create singularity. And he didn't say singularity, but they should come together. So, that property was used by Roger Penrose to show the singularity of matter, that without singularity, that we cannot exist. singularity is part of nature. And that's what Roger Penrose showed. What is singularity? Where the matter would become zero volume. And then I have the Oppenheimer Snyder equation, where he showed that a gas cloud would compress beyond the neutron star stage and all the way become a black hole. So that I have that. And then I have Roger Penrose's cyclic conformal universe theory, which is basically Roger Penrose's theorizing that there was a universe before the Big Bang, and that universe created some black hole collisions, and these black hole collisions have left a signal in the cosmic microwave background radiation. And he's showing some concentric circles in the cosmic microwave background radiation as evidence for the black hole collisions of the previous universe, which nobody agrees except for a couple of people. It's not a theory that has any validity. He doesn't connect why would a black hole collisions in the previous universe would create a sign in the mark in the cosmic microwave background radiation. But anyway, only thing I decided to put this in my YouTube was that he has a lot of good ideas. One good idea is that the cosmic microwave background radiation had maximum entropy. That's how we started. That's how the Big Bang started, with maximum black body radiation. That would be the maximum entropy. But if you look at the universe today, wherever we look, entropy is going up. So it's a conundrum. How could the maximum, if you start with maximum, and how could the entropy would go up? And Roger Penrose posed this question and nobody has answered it. People set aside as, can answer that question. So that was one of the reasons why I decided to put this Roger Penrose cyclic conformal universe. And future material, I would have the Reimann tensor, Ricci tensor, and the Ricci scalar, stress energy tensor, and the singularity, the Dirac equation, the standard model, all that. So stay tuned. And in artificial intelligence, I have TensorFlow, artificial neural networks, single and multi-variate analysis and its applications to, I picked reservoir operations. Then I have convolution neural networks. I got machine vision, image classification. Actually, I have MNIST database, which is very important. Database, MNIST database. And natural language processing, I have the tokenizer, sequencing, how to develop a tokenizer for Sinhala language. That I have transformers and machine AI in reservoir operations. So I would have more stuff on this subject, as time goes by. And I have a Bitcoin course, Bitcoin white paper by Hitoshi Nakamoto, the originator. I got the cryptographic hash function and how that was used to secure the blockchain. What is the blockchain? What is the blockchain contains? Why you have to secure it? How you secure it using the proof of work method and the proof of stake. This is another method, because as you know, the proof of work method takes a lot of energy and a lot of electricity, and that's being criticized in this today's world, global warming and all that. So Ethereum came up with the proof of stake method. And then I have the nonce field, which is also goes to the securing the blockchain. And the Ethereum hash function is a different hash function than the Bitcoin hash function, that is called the KEKAC 256. I have the working of that hash function. And I also have, some people say the quantum computers would break through this proof of work method and the proof of stake method too. But most people don't, real people who knows the mathematics don't believe in that, because you could always make the hash function. Hash function is a one-way function. you could always make it more and more difficult. There is no limit to making it difficult. So that's the thing. If quantum computers could break in certain function, then you could, all what you do is make the hash function more difficult. And I have shown, if you understand the hash function, the operations of it, you would clearly see what I'm talking about. And I have a foreign currency course, the Elliott wave method, pitchfork method, candlestick method, call, put options, foreign currency futures, and geometric Brownian motion, which is a stochastic method applied to foreign currency tradings. And I have mathematics. I have the Gödel's incompleteness theorem. And when Kurt Gödel became old, he lost his mind and he just became a little crazy. And he came up with a proof of the existence of God using logic. It's nothing serious. It's just some crazy person's rendering. But I thought it was interesting. It has mathematics on it. It's interesting, so you could take a look. And now the question is, the mind a Gödelian machine? What is Gödel's incompleteness theorem says? It says that any system starting with assumptions and rules would have statements that can be proven. At the same time, he proved that there are some true statements in that system that cannot be proven. So you have true statements out there that cannot be proven. And in the case of the mind, and if we assume that the mind is a finite machine, the neurons and all that, there's it's finite amount of neurons and finite amount of connections and finite amount of changes, the plasticity, everything finite. The brain is not infinite. If it's a finite machine, are there any true statements that in that mind that we don't know of, but we cannot reach? So that was the question. And some people say that mind is not a Gödelian machine, and that was by John Lucas' paper, and he was the first person to come up with this idea with the mind is a Gödelian machine. And he believed that it is not, but his arguments are not that convincing. So anyway, you could read about that. And future material, I decided to put topographic Galois theory, which is very, very interesting subject. I don't know whether there's going to be any real world applications soon. There's trying to connect that with the universe, the topography of the universe. So we don't know that. Tensor calculus. So actually it should be topological Galois theory. And I'm trying to do tensor calculus, which would be tied into Riemann tensor and the Ricci scalar. Because that's the reason I stopped the general relativity, because I wanted to do tensor calculus before I go to the Riemann tensor. And I have financial mathematics, stochastic analysis, Monte Carlo simulation. Actually, I got an email from Azerbaijan, I think, Azerbaijan or Kazakhstan, some oil, some director of finance who do oil trading, and asked me the spreadsheets that I had for Monte Carlo simulation. And I have geometric Brownian motion and how these methods can be applied to hedging contracts. And so these things are there. In future, I'm going to do the Ito calculus or the stochastic calculation and its applications. And engineering, I don't have anything yet, but I'm trying to do the seismic design of multi-story buildings. And this is not available in YouTube much. Seismic wave acceleration, base shear, how to calculate that, flow shear, plastic hinge formation in steel beams to be precise, steel connection design, and the concrete shear wall design. So stay tuned, and There will be more material to come. Thanks for listening.